you see only the basic structure, okay, only the basic overview of the whole payroll system, okay, only the basic overview of the whole payroll system. So now let us see the diagram. So this is payroll system. Payroll system process will be there, and the process will be there, and to the entities which are associated with this process. Okay, check management, payment type, employee management, payment management, salary management, salary slips management. These are all the entities related, interacted with this payroll system process. So this shows only the overview, only the basic overview of the payroll system. Okay. Now let us go to first level DFD diagram. First level DFD diagram. Number 3. So first level DFD diagram. So here it is divided into subsystems or sub-processes, and also each will be related. That means the entities, the functionalities that will be related with each other, and we are going to use your data flow symbol also. Okay. So here this is an image, so I have to show one by one by closing it again and showing it another one. That's why it takes more time. So this is a payroll system. So these are the entities related. A more detailed structure is shown here. For salary management, for salary also generating the salary reports, for payment also generating the payment reports, employee management generating employee reports, for salary slip also generating the salary slip report, payment type management, taking the payment. Let's see, the more detailed structure is shown in first level DFD. Okay, so you can have more number of sub processes also. So this is the main process. You can have more number of processes. So like how you draw in use case diagram, in UML diagrams, every class diagrams can be different. That means the attributes and operations what you have used may be different from one person to another person. Like that in PhD also, whatever the processes you put and whatever the entities you put may be different from one person to another person. But here in your zero level DFD data flow, you have to just show the overview, basic overview of the system. Okay, so for example, in hospital management, you have your patient management, your doctor management, your receptionist, that management, then medicine part one management. Many kinds of management is there in a hospital. So for hospital management process, you can all link up all those entities who are related to hospital management. Like that for payroll also, for employees, for salary, for payment, then for any records to be maintained, for any reports to be maintained, you can add processes, you can add entities accordingly. And here in your, one second. Number So here, this is your second level DFD, where it shows again detailed structure from level 1. Okay, from level 1 we are again showing more details from level 1. So here it means we have forgot password. A similar one we have done in your hospital management also. We are checking the roles of access, then modules, different types of modules. All these modules are associated in module process. Okay, this is one related entity for managing the salary, for payment, for employee, for check, and for all of these. So all these entities are related with this process manage module. And again, we have sub processes for login, checking the credential, checking the also access. This is our sub processes. And this admin entity has again another process in case if you forgot the password, sending email to the user like this. Okay. And here in the same thing also, you can put a database using the data store symbol. So maintaining records, you can put record maintenance, record management like this, and you can put in a data store symbol. Okay, you can utilize all the symbols which we have discussed in data flow diagrams. Okay. So like that, you will be drawing your data flow diagrams. Sorry, by mistake I closed the window. That's right. Okay. So now that is one example. So we also have data flow diagram for quiz management. Okay, quiz management is also there, like how we draw the same diagram which I have discussed. So that examples I will share to the group. You can take the example for quiz management, even for ATM management, also whatever the projects you have done in your UML diagrams, you can draw DFD diagrams also. Okay. So let me share DFD. Okay. So the diagrams which I have shown you, that is one type which you can draw DFT in that way. And also these are the diagrams which I have discussed earlier in our previous classes for hotel reservation. So like this also you can draw. This is level 0. This is the basic information, and level 2 goes one step deeper into parts of level 1. Okay, so this is the difference. Level 2 goes one step deeper into parts of level 1. So like this it will go deeper, and level 1 provides a more detailed breakout of the context level diagram, that is from level 0 diagram. More detailed diagram, more detailed breakout of level 0, and level 2 is step it goes one step deeper into parts of level 1. So like this, diagrams, hotel reservation, this is the level 1 diagram. Okay, this is level 1 diagram where you have your entities, guest and admin. Guest is nothing but your customer, and this is your admin who's responsible for managing the hotel, and this is the process. Okay, this is the process. So form filling up, form reservation, all those and room information is given to the guest from hotel reservation process. And here reservation of cancelling information. So messages can be written in the data flow. Messages can be written in your data flow. So like this also we can draw DFV diagram. This is basic structure of hotel reservation. That is why DFD level 0 and DFD level 1 is this one. So here we are going little more detailed information. We are showing more detailed information of hotel reservation starting from level 0. So in level 1, so you have your reservation process as sub-processes, room selection process, reporting to admin process. Okay, and guest, he can do inquiry process, and inquiry process can collect data from down storage, up storage. It's like some kind of storage this particular hostel has maintained. So and another storage file is your reservation storage file. So like that you can utilize all the symbols which we have discussed here. So this is your symbols, process symbol. So this right side one only we are using in our symbol, okay? Left, not the left side one. We have two types of symbols, scan insertion symbol, Jordan and Code symbol. So we are following this symbol, okay? So you can also follow this one, but for our examples which I have drawn here, I have all drawn using this Jordan and Code symbols. Okay. So like this for hotel reservation, this is level 0, this is level 1. And again, if we go deeper from level 1, so it can be like this. The diagram can be like this. So you have many processes here, query process, reservation process, and cancellation process, hotel process, inquiry, waiting process, room selection process, confirmation. So all kinds of processes can be included. This shows uh, deeper information about hotel reservation. Okay, so reservation storage data is here, reservation data is here, guest is entity, report is entity, like this. Okay, waiting table, reservation file. So all this symbol shows the storage file. Okay, the data is stored here. So reservation storage. We can say reservation storage, waiting storage, reservation storage they can utilize here, reservation storage they can utilize here. So we can have n number of entities and with n number of processes in your second level DFD, because this shows more detail or more deeper information than your level 1. Level 0, only the basic information. Level 2, a little detailed information than level 1. And in level 2, a more detailed information you can show using level 2. So like this also, you can draw your GST diagram. And also the initial one which I have shown for payroll, system management, hospital management, like that also you can draw DFD diagrams, or like this also you can draw DFD diagrams. This is for hotel reservation system. Okay. DFD diagram for 10 reservation also it is here. One example for 0 level. This is I think we have seen in the last class, in the previous class. This is a 0 level DFD. Passenger is entity, admin is entity, railway reservation process. So these are the data flow. Reservation, cancellation, record information. These are the data flow. So for level 1 also, it is like this. We have reservation process, inquiry process. Reservation process has again sub-processes. It is similar to hotel reservation. Okay. And for level 2, like this. Okay. So what's similar? All the diagrams will be similar because level 2 always shows a deeper information about level 1. So most of the diagrams will be similar. Okay. This is, what is that? Ticket reservation, hotel reservation we have seen. Now one more example we will see, and yesterday I have shown you one. I don't know where I kept that one. Software. Just a second, let me check. Okay, it is here. Data flow diagrams. Okay. So let me share another example. So this is the diagram which we have seen last class. So the FD components, these are the symbols. Then for online shopping, DFD we have seen yesterday. Okay, this is zero level DFD. This is first level DFD. And in second level DFD, a more detailed structure than this will be shown. And for structure chart, this is what I was about to explain in today's class. So structure chart and hippo diagrams. So here in modeling, we have four types of diagrams. One is UML diagrams, and second one is DFD diagrams, and third one is structure diagrams. Fourth one is hippo diagrams. Okay. For structure diagram, this is like just drawing a chart which is derived from data flow diagram. It's just like a chart derived from data flow diagram. Okay. So here also we will be having modules. So some symbols we will discuss. We will have modules here, and we will have condition, we will have jump, we will have loop, we will have data flow. So first we will see modules. So modules will be like this. So this is the main module. These are the sub modules. And also we have library module, which will be represented using this symbol. Okay, this is the control module or the main module. These are the sub modules, and the other one is library module. So library modules are nothing but they are reusable, and they can be invoked from any module. Okay. And control module branches to more than one submodule. So control module will have one or more submodules. And library modules, they are reusable and they can be invoked from any module. Okay. And it is represented using this symbol. Next one is condition symbol. Here you show a diamond box. So this is nothing but a condition symbol. So in a module, if you have some condition applied on the module, then you can use this symbol and you can draw the diagram like this. So it is represented by a small diamond at the base of the module. So it depicts the control module can select any of the subroutine. So that means here, if the module, if your diamond symbol is here, your condition is here, you can either choose this module, left module, or you can choose this right module. So that is what it is said here. It depicts that the control module can select any of subroutine based on same condition. And for jump, that means we will be using an arrow shown pointing inside the module. Okay, inside the module. For data flow, we will be just putting from end to end. But for jump, we will be using an arrow drawn inside the module, inside another module. So this shows that it is the module, that the control will jump in the middle of the submodule. Okay, so this is the module we have, and this may be submodules. Okay, the second one, this is the control module, this is the submodule. If you put the arrow like this, that means the control module will jump in the middle of the submodule. So this is the symbol. Another symbol is loop. Loop we represent like this with this arrow. A curved arrow represents loop in the module. Okay, so all the submodules covered by loop repeat execution of module. So in this submodule, these two submodules are covered. That means the first and the second modules are covered. So these two will repeat its execution. Okay, these two will repeat its execution. So this is the purpose of loop. And finally, data flow will be represented a directed arrow with empty circle at the end. A directed arrow with empty circle at the end like this. This represents data flow in structured chart. Okay, so don't confuse with data flow diagram. Data flow diagram, it is just a directed arrow. But here, a directed arrow with a circle at the end represents data flow. So this symbol represents data flow. And next symbol is control flow. If it is control flow, that means it should not be an empty circle. It should be a filled circle. So filled circle, then this is a control flow. Okay. So these are the symbols. Control flow, data flow, loop, jump. Who is joining just now? Class today, almost maybe I'm going to complete this class because I'm not going to take up to 2 o'clock today. So if you are joining just for attendance, then it's of no use. So don't join just for attendance. Next, last hippo diagram. This is the last diagram. Okay, and normally for your exam purpose, we will be focusing on UML diagrams mainly. Important one is UML diagram. Next one is DFT diagram. Okay, structure chart for your reference. You study the symbols and what is structure chart. You study this one, but there won't be much questions asking from structure chart. Okay, because in your syllabus they have asked me to complete UML and DFT diagrams. Okay, but in your actual syllabus these are also there. Structure chart is also there and hippo diagram is also there. So that's why I'm just covering the topics. So structure chart, it is just a chart deriving from your data flow diagram, and we have certain symbols here: module, control module, submodules, library module, condition symbol, jump symbol, loop symbol, data flow symbol, and control flow symbol. Now the last diagram, hippo diagram is hierarchical input process output diagram. Hierarchical input. So from the name itself, you can understand something, right? Hierarchical input process output diagram. So this is a combination of two organized methods. So hippo diagram, as you can see here, it is very, these diagrams are good for documentation purposes. So it will be like this. Suppose of online sales, it shows a hierarchical structure. So your hippo diagram shows a hierarchical structure. So online sales is your management system, online management system. So you have authentication process, inventory check process, payment process, and dispatch item. So your inventory check has another two processes. One is issuing the item missing, and issuing the item without inventory, like this. So it shows a hierarchical structure. The hierarchical input process output diagram will show a hierarchical structure. Okay, so online sales here, it represents the hierarchy of modules in the software system. Hierarchy of the modules in the software system. So from this initial one, it will be composed into sub-functions in a hierarchical manner. Okay, so from this, we are going to decompose into sub-functions in a hierarchical manner. And that is what it is shown here: online sales, authentication, inventory check, payment process. So in a hierarchical manner, we are having sub-modules. We are having sub-functions. So this kind of diagrams are known as FIFO diagram. So this is just explanation. Structured English you can go through by yourself. There will be if then else statements will be there. Say for example, if you have if customer name found, then call procedure user password authenticate, like this. So even in authentication process, you can have structured English. Structured English, for example, if then else, do while until, if then else. So these are known as structured English that we use in our program code. Okay. So structured English examples it is shown here. If customer name found, then call procedure username, user password authenticate, else print error message. Okay. So if then else, like this. So similarly, we can also use do while until. There will be a loop. If then else also we have a loop. Do while until also we have a loop. And pseudocodes. Pseudocodes are written in this format. Okay. Like even for printing Fibonacci series, which you have done earlier in your C programming language. So in pseudocode, if you have to write, we will be writing like this. So just go through once all these notes. Decision table, how we are going to make a decision table, like this. Okay. So yes or no. Yes or no, but that means we will be having a condition. So we will check the condition. If the condition satisfies, then yes. Otherwise, the condition is not satisfied, then no. Like that, we will be having conditions. So this condition, if we represent in a table, we can represent in a table conditions or actions, like this. Okay, so these are the actions. So like this example particularly they have shown for in-house internet troubleshooting. So that means they will be checking some say check network cable. So if the condition is not satisfied, if the particular cable is not checked, we put a cross like this. Okay. If the internet router is not checked, we put a cross like this. So we are just putting the actions in the form of table. So it's nothing to worry about this table or example. Okay. Here what is important in this example is we can create decision tables. Okay, we can create decision tables in the form of using 4 steps. First one is identify all the possible conditions, then determine the actions that can be done, then create maximum possible rules, then define action for each rule. Okay, so normally for decision tables also we perform one testing, one kind of testing, that is condition testing or decision criteria. We call as condition testing or decision criteria, where a decision will be checked at a particular point. If the decision is found to be correct, then we go to the yes condition, and if it is wrong, we go to the no condition. So from that, we can create a table. So if this condition is right, then go through. If this condition is wrong, then go to this step. Like that, we can create a decision. That is about decision tables. Finally, and ER model also, I think you have already done in your database. So entity is nothing but your object and relationship. So entity may have attributes, like in your UML diagram, we have attributes for a particular class. So like that, for entity, we have attributes. So if it is student, then student name, student ID, like this, okay? So it has a relationship with a teacher, and teacher's name, teacher subject name or subject responsible that particular attribute you can write. Teacher's phone number you can write, teacher's address you can write as an attribute. And there will be relationship. So relationship, you can give some name here, you can give some mapping here, like that. So ER model is nothing but entity relationship model. So as I told you, this one is already done in your database. Here we are just understanding the idea how the entity relationship model has been constructed. Okay, entity relationship model. So this is how it is constructed. We have certain entities associated by a relationship between them, and each entities will have attributes corresponding to it. Okay. If it is student, student name, student ID. If it is teacher, then teacher's name, teacher's ID, teacher's phone number, teacher's address, like that you can put certain attributes. See, student is the entity, student has various attributes like name, ID, age, class, etc. Okay, so example also is shown here. And in this relationship, we can have mapping. Just like what we do in drawing our class diagram, in between the classes, we put a mapping. So here also, mapping can be done here. One-to-one mapping, one-to-many mapping, many-to-one mapping, and many-to-many mapping. Okay. Okay, so we will wind up our class for today. These are also other related notes. You can check it. I have already sent this one.
Ma'am,
Yes, yes, yes.
ma'am, for exam point of view, structure charts and after that the notes structure English, these are not important. So,
For exam point of view, you can focus on DFD and UML diagrams. For
okay,
exam point of view, okay.
okay,
And SRS also, in exam point of view, it can be asked in the like what are the certain rules for developing the SRS, like that you can study. Okay, but these are just for your reference. For your reference, how the condition table is met, how you have your structured English. So these are just for your reference. These are all important in making your in developing your software design. Okay, software design, when you develop a software design, these are all important things to be considered for designing a software. That's why these are all given here. But for exam point of view, you can study DFD diagrams, UML diagrams. And for example, if I say HIPPO, like hierarchical input, process, output diagram. So what does HIPPO signify? Like that, I may ask a question where you have to answer. It represents the hierarchy of modules in a software system, and this diagram is developed in order to obtain the high-level view of the system functions. That means it decomposes into sub-functions in the form of hierarchical manner. Like that, you need to understand what is HIPPO. Okay. Okay, so DFD, you have to study, then you have to study UML, and you can just study some information about HIPPO also. Okay. Okay, so this notes already I have sent you. For once you can go through and you can check out what are the other important factors responsible for software design. Okay, in order to develop a software design, you need to know your entity relationship model. You need to know decision tables. You need to know pseudocode like this. Okay, let me take your attendance. Roll number 1,
Present, ma'am.
roll number 2, roll number 2, Akash, absent. Roll number 3, absent. Roll number 4,
Present, ma'am.